Welcome to Section 9.2 for General Psych 105. So we're going to talk a lot about kind of assessments, what scores mean, and then biases that exist or may not within testing and what is a bias. So we start with talking about standardization, and pretty much what a standardization is we have matched this with a larger population and figured out this is where the average person at this age or this group fits. So when they design IQ tests, going back to kind of the 9-1 example, they assess 10,000 8-year-olds at their reading level and their math level, and that standardizes it. This is what the average 8-year-old performs at. They do this for adults, they do it for children, they do it for adolescents, and this standardization gives us kind of a baseline of where scores are, and these are our norms of what kind of quote-unquote is normal and what is abnormal. So the data that comes out of this is we have this normal distribution, which we'll look at a graphic here in a second, or this bell-shaped curve. Like mentioned before, an average IQ is a 100 on the Wechsler Adult Intelligence Scale. One standard deviation encompasses 15 points. So if you're within 15 points below or 15 points above, you're of quote-unquote average IQ. And then the Stanford-Binet is a 16-point scale. So looking at this graphic here, if your friend has an IQ of 105 and you have an IQ of 110, statistically speaking, you're both of average IQ. If you have an IQ of 120 and your friend has an IQ of 110, then you are as above average IQ. And this works the same way if we go backwards looking at 85 and 70. The terms that are used for people that fall 2 standard deviations above are gifted, and the 2 standard deviations below do fall in a range of mental retardation. As far as kind of psychological terms and evaluation, I know that there's pushback from some educators on the term of mental retardation. For test purposes, you need to know this. So within standardization, there is kind of a constant standardization that's occurring, and what we do see is it's kind of test difficulty and scores push forward as time goes on, and this is what's referred to as the Flynn effect. It's not saying that the IQ score that your grandparents may have taken is any more difficult, or that you're considerably smarter than the generation or 2 generations before. It's that there are changes that are occurring within the education system, and so the Flynn effect shows that this trend of changes occur. So some of these possible explanations are that there's just better health and nutrition, there's better education, more education is made available to more individuals, there's increased opportunity for learning, and then there's improved test-taking skills. And we see school systems start to hone in on these skill sets to help students learn better. So the trend doesn't necessarily indicate that one generation is smarter than the other. It's that the resources made available may be better. So conversely, today's score of 70 signifies that one's barely able to function unsupervised, and a large number of individuals in the 50s would have achieved the score even though they were working full-time jobs. So when we're looking at IQ, it's this kind of malleable process that's occurring, and it changes over time. So a couple of notes that we need to be aware of in terminology is reliability. So the concept of reliability is this idea of consistency. A test is reliable if it produces the same results kind of over and over and over again. So if we go to like the SAT as an example, if you took it your sophomore year in high school and you scored 1,000 on the SAT, and then you took it again your junior year and scored 1,000, and then took it again your senior year and scored like an 1,100, we would argue that that test is pretty reliable. For the most part, your score remained relatively constant throughout. Now, because there's some fluctuation in the score, it doesn't mean that it's not reliable. We need to look at it as if there's drastic deviation, for example, what's provided here. And so we have this test-retest reliability, which is a coefficient, or this correlation that ranges. And like we talked about with correlations before, you can't go over a 1 because that's a perfect correlation. So the closer we get to approaching 1, the stronger the strength is of that test-retest reliability. The closer we get to 0, is the less reliable. Most IQ tests have a pretty strong reliability, a coefficient around 90, which means that your IQ remains relatively constant throughout time. It does increase up to about the age 25, and then at 25 it kind of baselines, and then we do see a bit of decline as we get older. Probably more to cognitive functioning speed than necessarily not being as intelligent, as well as when you're, between 5 and 25 years old, this is where most of your learning is occurring. So now we're going to talk about different types of validity. So what validity means is it kind of asks, is the test actually assessing or measuring what it's supposed to? There's a couple of different types of validity that we're going to talk about. So content validity is the content of the actual test, the items in the test, designed and measuring what they're supposed to do. So for sake of example, if you're taking a math test and it just gives you like 2 plus 2 or 4 plus 4 or basic kind of mathematical questions, we could argue that content's quite valid. If we start getting into word problems, which start using big words or language that people may not understand, this may not have the content validity because the question may ask a deeper understanding of what's your reading comprehension, not your mathematical ability. So when we're looking at kind of, IQ tests and the validity of IQ tests, there is data to show that IQ tests have quite a bit of validity. The design for most IQ tests is to kind of look at performance, whether it's job performance or academic performance or things like that. So IQ tests do have a prediction of variety in jobs, and so they have some real life application. Like I mentioned in the previous section, there is a correlate to like percentages of car wrecks and IQ scores, so there's some validity within that. So some of our problems with measuring validity is that it has predictive validity only in a population that has varied scores. So if we have a really high stringent acceptance rate, like at a university, it's really hard to assess like predictive validity, which is your ability to predict outcomes in this. Because if the only people you look at are the top 5%, then we don't know if performance of the lower 95% are predicted on this test. The GRE is one of these tests that falls in this kind of realm, is it doesn't have a very strong predictive validity because a lot of graduate programs have a cutoff, and if they're only accepting, the top 25% of people or the top 20% of people, the other 80% are moved out of this data assessment, so it's hard to predict the actual validity of tables or assessments. Utility comes down to, is this test actually useful? So one of the things that is kind of questioned or debated is the utility of like the SAT versus the SAT subject test. Is one any more useful than the other? And so what they're finding is that first-year graduate students, are equally predicted from the subject score as well as the SAT alone. So we would argue that the utility for both of them to be necessary to get into a program wouldn't be needed. We could use one of them because they have just the same predictive validity as the other. So the utility of a test comes down to, is it useful in its application? So when we're looking at these fluctuation in scores, we can argue that IQ tests for infants are relatively low reliability because the scores are going to go up unless there is some type of severe cognitive deficit that's occurring. Now, getting into the idea of bias, where this term gets kind of confused, is a test is biased if it underpredicts or overpredicts the performance of one group over another. A test is not biased if the actual prediction is accurate. So we'll just take gender as an example. If a test predicts that females will perform better in school than males, and the outcome of that is accurate, they take the test, females do better on the test, and then we look at their GPAs and females have higher GPAs than males, that test isn't biased. It's only biased when it says that, you know, females performing at this level do better than males performing at this level, and then we look at the GPAs and find out that males are performing better, and the test has under predicted male performance. Now that test is biased. So there is some single content bias that may occur, and this is where if the language is used and one group doesn't understand the language, or if it asks about certain circumstances where one group may be underrepresented or underinformed, there can be bias within the content validity of this particular test. So as a whole, if it underpredicts performance or overpredicts, then we argue the test is biased. If it has accurate prediction of performance in school or in work and things like that, the test isn't biased. So as we start talking about stereotype threat, this comes out of Claude Steele's research, and what stereotype threat shows is that when a group is matched against another group that they perceive to be smarter, faster, better, etc., we tend to see the performance of one group go down because of this threat that's present. So what ends up happening is, for sake of example, if we think about this in a sports analogy, if you've ever played like the state champions, or you've gone up against a team that has like X amount of college, like signed college recruits that are going to Division I schools, and you go out on the field and just get absolutely crushed. It may be that that team is just better than you. It could also be that now there becomes this kind of cognitive message that starts going, oh my gosh, they're so good, they're so much better, they're so much faster. And instead of you performing to what your level could be, your performance starts to decrease as a result of this perceived stereotype threat. So within group differences and biases, this is a pretty politically charged issue. Again, just being mindful that a test is not biased if it accurately predicts performance. So if we just kind of look at graphic representation here, for IQ score changes and things like that, when we see increases in scores for different demographic groups, we are seeing increases across the board for a lot of demographics and increases in school performance. And so some quick notes on heredity and IQ scores and environment. This falls in this nature-nurture argument. There is data to show that there's a pretty decent correlate and relationship between heredity, that if mom has a high IQ or dad has a high IQ, you're likely to have a higher IQ score, as well as, if mom or dad have lower IQ scores, your IQ scores are most likely to be lower. Where the mix between kind of nature and nurture comes in here is if parents have higher IQ scores and more resources made available to them due to those higher IQ scores providing them better jobs or college degrees or higher income, then that's also going to shift your environment. Versus if you have parents that have lower IQ scores, lower resources, that's also going to shift your environment. So it's a mixed bag of both. There has been some data to show we have environmental changes occur. IQ scores, adjust accordingly, and it's bidirectional. So if you increase or enhance resources made available in the environment, we tend to see IQ scores go up. If we decrease resources made available, then we might see a deficit or a drop in IQ scores. When we look at adoption studies, there's the correlations in the data does show that it tends to reflect biological mom and dad's IQs than it does environmental. So most researchers do agree that it's a mixed bag. There is a genetic kind of component that plays a role here, as well as environmental cues on adjustments in IQ scores. So the discussion on IQ and intelligence, it is debated, it is discussed, which is a good thing because it allows us to continue to evolve this process. Genetics play a role in your IQ, environmental factors play a role in your IQ, as well as academic performance.